Um, I'm excited mostly about the New England Patriots won the Super Bowl last week. I graduated from the University of New Hampshire, which is just north of Boston, which is just northeast of Foxborough, where it all happens for us. So really happy to be here tonight. As Dennis mentioned, my title at EMC is EMC Fellow, and a fellow is a career path for a technologist. So if you don't want to manage people, it's nice that EMC has a path for you to stay as a technologist. So I'm in my 29th year at EMC. 25 of those was spent as a software engineer building EMC's products. And the last 4 years I've spent working for EMC's Chief Technology Officer, John Rose. And when you become an EMC Fellow, you automatically become a Vice President. Right, and most software engineers don't become vice presidents, so when that happened to me, I said, well, what's my title? Vice President of what? So I made that up, Vice President of Strategy and Innovation. And my boss liked it because basically, as the Chief Technology Officer of EMC, it's his job to create the overall technology strategy, to see what's happening in the industry, and to communicate EMC's strategy to the public, to our customers, to our partners. And so that's my job, right? Part of my job today is to describe a vision for where we see the technology industry heading. But in addition, I'm supposed to share this vision with my coworkers, the engineering team inside of EMC, to help innovate and help to build next generation products and services based on that strategy. And our topic today, data value, falls into that category, right? It's not something that a lot of people are talking about, the economic value of data. And it's certainly not something that EMC's engineering team or VMware's engineering team, we're not building products and services today that help calculate data value. So today, my goal is really to talk about what we see coming in the area of data value, and also to talk about what is the possible impact on the IT infrastructure. And I have never talked about this topic before, and I thought this is the perfect place to discuss it because you're IT people, right? And I'm looking forward to the conversation afterwards about whether you think this is real, whether you think there will be impact on the IT infrastructure. And when you talk about data value, this morning, Dennis actually picked me up at the airport. And I started telling him about my presentation. Well, Dennis's role at EMC is data architect. And I said, well, what does a data architect do? And the high-level summary is he has to find at EMC all the sources of data in his business unit and try and move them into one repository, into one location. And these databases are spread out all over the world. So first he has to find them, and then he has to move them in one location and try and generate value for our business. And so I asked him, as part of your day-to-day job, do you ever calculate or think about the economic value of your data? And his answer was, no, I do not. But the activity of bringing together all of that data in one place, he thinks, well, will be the enabling function, right? Once it's all together, then you can actually work on techniques like that. So today what I want to talk about is, as he's building this business data lake, is what we call it, putting all the data sources in one location and then trying to extract business value out of it. Is there anything that his team should think about in terms of data value? So let's take a look at what we mean by data value. Some very public examples, right? This is from an article that I found in the Boston Globe. There's a hospital that 800,000 patient records were breached, and they were forced to pay a settlement of $750,000. So the value of each customer record was a little bit less than $1 per record, just in terms of the penalty that they had to be paid. TJX, likewise, they had a breach of 46 million credit cards, And the estimated cost for them to recover from that incident, $180 million estimated. So over $4 per customer record. And then finally in 2011, Sony had another breach earlier, 4 years ago. 100 million users and an estimated cost to them are $171 million. There are actually research institutes that study the cost of data breaches. And one of them is estimating it's actually a lot of smaller companies that get breached. It costs $188 per customer record. So from a negative standpoint, if you're running a company, you will probably you're going to want to assume that you might have some breaches. You might want to assume or try and calculate somehow what's the future economic value of those bits of data that are being breached. On the positive side, we have, there's a company called 23andMe, and their revenue model is they sell DNA kits for $99 per kit. And then you send the kit to them, and they will take all of your DNA data and store it for analysis and give you a report. And so if you look at those numbers, they've generated almost $80 million in revenue for that data set. Several months ago, they were approached by a company called Genentech, who said, we would really love to run our algorithms over your data. And they gave 23andMe $10 million for starters, and depending on how the research goes, they could spend as much as $50 million. So if you look at those records, right, that data rose in economic value. So we're seeing more and more cases of this example where companies are trying to take their existing data assets, and if they know the potential economic value of those data bits, they can really help their company by either taking measures to prevent breaches on really expensive data that has a negative impact, or trying to position and save their most valuable data in terms of revenue generation. So let's ask, so I, as an inventor, and as we talk about the strategy of how can we leverage this potential trend of data value, I'd like to ask a few questions. First of all, who determines the value inside a company? What is the process that they use to determine value? And especially from my point of view, as someone trying to build products, data center products, how can the infrastructure support the people that are evaluating the data value and the process that they use? And the truth is that I have no idea about any of these answers, right? Because we're really at the beginning stages of data valuation. But we actually found a research partner in San Diego, California, and Professor Jim Short, his specialty is data valuation. So I've gone to him, I visited him several months ago, and I said, he's not a computer scientist, he studies business. And so he's actually beginning to visit companies and find companies that are participating in data valuation. So he's trying to find out about the people who do data valuation and the process that they use to evaluate data. And this is one of the more interesting things that he's found. There are actually startups who are visiting large companies and small companies and selling insurance policies on data. So this would be a fantastic example for us if we could understand this growing trend, to understand how these startups, if they go into a company like EMC, how would they go in and ensure a data set against breach, being stolen, corrupted, or being lost. So our first effort here with this research is to have Professor Short interview these startup companies and say, when you go into a business and evaluate create a data insurance policy, how does it work? And the thinking is that the more we understand about the people that are involved in the process that they use, then we can understand the impact on the IT infrastructure. So this is what we've kind of pieced together so far. Picture this underwriting process that a data insurance company could potentially use. First of all, they walk into a corporation like mine or another startup that wants to insure their data. And they say, well, we need to identify what data set or what data sets do you want to insure. And this means that the company typically needs to have an audit and inventory system that lists all of their data assets. And I believe, this is just a hunch, that no company has a list of all of their data assets, right? So typically the data insurance company would have to create this system because they're going to want to come back in time and time again and audit from the same place. But the people that they first contact, the data insurer, they would contact somebody like Dennis. They would contact the data architect. As I mentioned, Dennis's job as a data architect is first of all to find all of these data sets and then move them into one location and actually create this audit and inventory system. And Dennis is doing this in the context of his own business unit, for example, manufacturing. But what we're starting to see more and more is there's this new role of a chief data officer emerging in many companies. So there might be many architects like Dennis reporting up into one chief data officer. So when a data insurer comes in to a chief data officer, he understands the business value, and the data architect understands where is the data set, for example. So the next step a data insurer would want to know is, how much risk am I taking on by insuring this data set against loss or theft? So they need to evaluate the data protection strategies that are specifically used for that data set, which means they would need to interact with the chief security officer, for example. And what we're finding here is that most companies don't have an auditable way to express all of their data protection strategies for a particular data set. So usually it's quite a manual process where a data insurer would have to read through specifications, interview people at the company, but nothing automated. So after the risk has been evaluated, how well is that data set being protected? The next step would be the underwriting process. How do you evaluate the data? How does the insurer generate the rates and the premiums that would be involved in insuring the data? And for this, you actually need someone from the business side of the company, again, the chief data officer, but also a data analyst. So a data analyst could actually show the algorithms that they're running on the data and express to the data insurer, why is this data valuable? Right? So actually run those models, run the algorithms, do some analytics, and express the value of the data to the corporation and why they believe it's that valuable. And the insurer is going to turn around and say, okay, I'm generating a premium for you that you need to pay monthly. And I'm going to write up an insurance policy, and as part of that policy, you have to guarantee a certain level and implementation for your data protection. And if you don't keep this level of data protection, and I audit you and find out, then the insurance policy is void. So in addition to a chief data officer and a data analyst, you need the chief information officer who has access to all these systems that can provide those audit reports at the snap of a finger. And then finally, once the insurance is in place, then you have audits, claim investigations, and once again, your chief information officer and your chief security officer and their staff is going to need to be involved. Make sense? Fairly straightforward scenario. Again, this is not happening a lot, but it's happening more and more with the data breaches that people are experiencing, right? They They feel as though they're not able to plug all the holes, and they're worried about certain data sets, and so they're exploring this data insurance option. And this is just one use case, right, of evaluating data. And this is the one we've decided to explore during this talk, the data insurance use case. So let's move to the IT infrastructure. And what we're seeing in the industry is our customers are starting to build a new form of IT infrastructure. And that form has 3 layers, and I'll explain each one. But the thinking here is, as they're building this new infrastructure, is there anything they could do or add to each layer to address the data insurance use case? And by addressing that data insurance use case, would that position them to evaluate data for other use cases as well? So I'll talk about each of these layers in detail. Again, our customers are building a new data storage layer, they're building a new cloud management layer, and they're building a new application deployment layer. So I'll talk about this new data center that they're building, and then at the end of the presentation I'll talk about, well, what do you do with your existing data center as well? So let's talk about this data storage layer. We're calling it a software-defined storage layer. Essentially, there's a piece of software in most modern data centers. When you have new applications that want storage, they go to the layer and they say, I need some kind of data storage. I may need a file system. I may need a database. I may need an object store. I need a certain level of performance. I may need flash drives. I may need spinning disk drives. And the job of this layer is to look down upon all of the infrastructure. And here at the bottom you see a hot layer that has solid state storage with very low latency. And then the green layer is a spinning disk layer. And your colder data that's less frequently accessed would be moved down. So the job of this mapping layer is when an application comes in and says, I need storage, then it's handled by this layer. And the customer doesn't have to worry about allocating it manually. So what's the value of this? Many of you are familiar with how VMware has worked for over 10 years. Customer wants to deploy a new application. VMware asks the servers, how many servers do I have? How much CPU do I have? How much memory do I have? And then VMware places the application on the right server. Well, several years ago, VMware bought a company called Nicira. And Nicira can go to the network switches and say, how many network switches do I have? How many ports do I have? How much bandwidth do I have? And then VMware can place the application on the server, provision the network, and now with this approach, they can identify how much storage they have, and they can provision everything all at once. So that's software-defined storage. The question is, how does this work for the data insurance use case? So if I'm in the company doing the insurance, when I come in for an audit, I want to make sure that the data that you stored on these disks is protected adequately. And so I need to add something to this layer, which is essentially a trust taxonomy. I need the storage layer to report out on at least 6 different security and trust attributes. Security, the availability of the data, how easy is it to manage, how transparent is the system, how serviceable is the system if it breaks, and is it sustainable from the standpoint of how much energy is used to spin the disk drives, or where are the components from, and are they manufactured in an ethical manner? So what we're suggesting for this layer is that customers who are concerned about data value in the future actually introduce a trust taxonomy and begin to surface that up for the storage layer so that when someone comes in and does an audit and says, where are you storing your data? You can very clearly articulate, well, I'm storing it on a storage system that has these specific characteristics which have been reported to me by the devices themselves. Does that make sense? So let's move up right above the storage system layer. We have tools like VMware. And I managed VMware and as a cloud software can automatically take an application and now it can provision the server, the network, and the storage. And this looks something like this. It's software-defined data center, automated workload mapping. So now as applications are being deployed onto an infrastructure, tools like VMware can look at the servers, the network, and the storage and do a best fit placement based on all of that software-defined data that's coming back to a tool like VMware. However, this tool is not reflecting trust data coming up from the storage systems. So your cloud software needs to export the trust services that it sees in the underlying infrastructure. So again, a tool like VMware in the future is going to have to understand the trust characteristics of the servers, the network, and the storage, and then advertise those capabilities to the application. You see where we're going with this, right? We're basically taking trusted infrastructure semantics, and we need to somehow push that up to the application level so that when I want to assess the value of the data, I can actually map it to the level of trust that I have underneath. So let's go up one more level in the stack. So this is the third thing that most customers are doing, this application deployment framework. They're using a platform as a service or a container deployment approach to abstract themselves away from where the data center is. So for example, on the bottom, I may have 7 different data centers. One of them could be Amazon. One of them could be Google. One of them could be VMware. One of them could be a private data center. And each one of those data centers, based on the hardware, has a certain level of trust services built in. But today, that's not part of the deployment process. Today, if I want to deploy one of these applications, I send a deployment request to a tool like Cloud Foundry, for example, and I say, please deploy that application onto a VMware cloud, or a Google cloud, or an Amazon cloud. So in essence, you have to choose the infrastructure where you want to deploy the application. So again, that won't work in the data insurance use case. What will work is we need to create some sort of metadata repository. And so instead of a data lake, we're talking about something called a metadata lake. And I need to store in that repository information about the application policies. For example, is there a data insurance policy on this application? And what areas of trust and what areas of protection are required by that insurance policy? At the same time, I need all of my data center infrastructures to advertise and store the level of trust services they have in their cloud and put that into the metadata lake. So now when a deployment request comes into this level, there needs to be some technology added to this called governed placement services. So when an application comes in to a platform as a service environment, no longer in this use case will a person be saying, I want to store it on Amazon, I want to store it on Google. They'll say, I want to store it on the location that has the appropriate level of trust service and trusted infrastructures for this insurance policy that I just bought. And once that governed placement happens and is deployed, you go back to the metadata lake and you said, I have just deployed application ABC onto infrastructure XYZ at this date on this time with these trust policies. And so now I've created this audit trail for my data insurance policy. And so the data insurance use case has been helpful in seeing, well, how can do we need a brand new architecture? And the answer is no. We can still use the architecture that a lot of people are building for their new data centers. But we need to augment each layer to take advantage of, or to satisfy the requirements of the data insurance use case. So the overall picture, again, of your people and your processes and your infrastructure, on the left, when you're building a brand new data center, you're using software-defined storage, you're using software-defined data center, you're using a deployment framework. On the right-hand side, your business people, your chief data officers, your data analysts, they're participating in this platform as a service layer by feeding their requirements and their policies for the application down into the metadata lake. On the bottom side of this application deployment framework, you have your infrastructure team, your chief security officer, your chief information officer, who are working on taking the advertised trusted infrastructure services and also putting this up into this mediation layer. So this really, the data insurance use case has been helpful in identifying who are the players, what are the processes that they use, and how is the infrastructure to be structured based on this. So this is the big marketing slide finish, right? This is your business data lake, but I like to call it a valuable business data lake because you've created this centralized repository of trusted infrastructure. You're able to drop all of your applications into this business data lake, but on the side you have this metadata lake, which is essentially governing the location of these and doing the mapping between the application and the data where it's stored. So the final slide is what happens, how do I get there from here? And you can't do it all in one slide, but I'm going to give you a little hint of the way we think customers can actually deploy this in their existing data centers without doing something new. What they need to do is they need to inventory every single application that they have, right? And we're thinking that the first third of the applications that they discover could actually be decommissioned, right? There's studies that 20 to 40% of applications that are running on mission-critical IT infrastructure could actually be retired and moved to a cheaper archival storage repository, which is searchable, has retention capabilities, compliance capabilities, and by the way, that's called a trusted infrastructure. So if you can actually retire those applications and move them over into this type of storage, create a metadata lake and record those associations in the metadata lake, you've now just created a trusted infrastructure and a compliant infrastructure by doing yourself a favor and moving all of your non-mission critical applications into a new infrastructure. And the second phase is a little bit harder, and this is what Dennis is doing right now inside EMC, right? He's identifying those next generation applications that are mission critical, that need to stay up and running, but somehow he needs to figure out how do I move them into a different centralized trusted repository, and how do I take those applications and move them over into that central repository, and then how do I update that metadata information to go along with your metadata about your decommissioned applications. And finally, while all this is happening, customers need to build a brand new infrastructure, right? That has that software-defined storage layer, it has that software-defined data center, it has the deployment layer. And so as you push up towards 100%, now things are happening in an automated fashion. Applications are being deployed in accordance with policies for that data. So, my final comment to you, thank you for your patience. I hope that you found this topic interesting. Another reason for me coming over here is to just let you know, we are a couple months into this research with University of California, San Diego. If you want to get out of Ireland this winter, there's still time to take a trip to San Diego, sunny San Diego. And you can certainly email myself or Jim if you or your customers or partners that you know want to learn more about this trend, both from a data valuation standpoint and an IT infrastructure standpoint. So with that, I'll say thank you and open up for questions.